Today, we're going to learn how to manipulate a linked list using the node class. Hello, I'm James Helfrich. In order to manipulate a linked list, you need to be familiar with the node class and the pNext and pPrevious pointer. This is a bit more complicated than working with a container when we don't have to worry about those implementation details. However, with a linked list, we're kind of forced to. So this video is going to demonstrate how to manipulate a linked list using nodes.
To construct a node, we have three constructors: a default constructor, a copy constructor, and a move constructor. In addition, we also have a copy method, which will make a copy of a linked list. We'll start with a simple node definition that has those three constructors: a data, and a pPrevious, and a pNext. To use this new node class, I have to first declare a node variable. This is a template variable, so I have to specify the data type, in this case an integer, and I'll call this node1, and I have to allocate it with a new node int, and this is going to be called a default constructor, which will fill it with the data value of 0. And sure enough, it's 0. Notice pPrevious and pNext are set to the null pointer. Now I'll call the non-default constructor, which will be the copy, which will copy a t value, and now I'm going to initialize data to 100. Notice how pPrevious and pNext are also set to null. Now, in order for me to create a linked list, I have to manually hook these up ourselves. So I want to make a linked list of size 3. And I'm going to fill it with the values 100, 200, and 300. Now, right now, I just have 3 nodes independently created, so I have to do the work myself to link them together. So node 1 arrow pNext is N2, and N2 arrow pPrevious is N1. Now, N1 and N2 are connected. And I have to do the same thing with N2 and N3. When I'm finished, then I'll have a linked list with 3 nodes. And N1 will be the head node. So when I compile it, I will see that N1 has data 100, pNext is going to refer to the 200 node, and pNext is a 300 node, and notice pNext after that's the null pointer. Now I can also make a copy of this, and I'm going to create a new node for this, and I'm going to call this pCopy, and this is going to be, I'm going to call the copy method, and the copy method will take a node pointer as a parameter. And this will go through and will create 3 new nodes, which are going to have different addresses than the N1, N2, and N3, but it's going to copy the data. Notice how they have different addresses, but the data has been copied over, and that's how copy works. Now we have 2 assign functions: the assign function, which will copy the values over, and the swap function. In order to demonstrate the assign operator, I first have to create a second linked list. And I'm going to create a linked list that has 1 node, and it's going to have the value 999. All right, so now when I call the assign method, it's called assign, and it's assign destination, comma, and then source. And now what I'm going to do is I'm going to copy the values from N1, N2, N3 into copy. Now copy only has 1 node initially, so it's going to have to allocate in 2 nodes, 2 new nodes, to accommodate the values of N1. Notice how N1 retains this value. All right, now if I call swap, what swap is actually going to do is just trading the pointers between pCopy and N1. Notice how copy has 100, 200, 300, and N1 just has 999, so they swap the values. Now, if I reverse the order of swap, it's going to behave exactly the same as when the order was straight, and that's just because I'm just going to swap the values. And once again, N1 still has only 1 node with 999, and pCopy is going to have the 3 nodes. Now, when I call assign with the opposite values, now I'm going to assign the 999 onto the old linked list that used to have 3 values. When I'm done, both are only going to have 1 value, which means the old linked list had to delete or had to remove 2 nodes in order to accomplish this. Now, there is no iterator for the node class, but we can iterate through the values using the standard for loop for p equals the head node, p, which means as long as the pointer itself is not null, p equals p arrow pNext. Now, to demonstrate how this works, I'm going to use exactly the same 3 node linked lists I had previously. Now, my iterator variable will be p, be a pointer to a node, equals n1, the head node, p, which means as long as I'm not the null pointer, p equals p arrow pNext, I'm going to advance my pointer to the next pointer in the linked list. Now, to demonstrate that this works, I'm going to multiply each value by 100. So p arrow data equals 100 times equals 100. So I should expect 10,000, 20,000, and 30,000 as the values of my linked list. So there's 10,000, 20,000, and 30,000. Now we have no methods to access the elements in a node. We just look at the element directly by arrow data. So to demonstrate this, we'll start with the same 3-node linked list I had before. And what I'm going to do is I'm going to independently change each value by assigning it to 400, and then 500, and then 600. Notice how I can access them directly without a method. And so when I run this, then I expect my linked list to have 400, 500, 600, not 100, 200, and 300. And sure enough, there's 100, 500, and 600. Now we can add a new node to the linked list with the insert method. This takes a node where we're going to insert it to, a t, which is the value we're going to add it to, and a bool, which is I'm going to add before or after the current node. So let's demonstrate this with our 3-node linked list we had previously. So I'm going to insert at node n2, and the value, let's say 999, so that will be easy to find in my linked list. So when I run it, I'm going to discover that n1 is 100, n2, oh, look at that, 999, then 200. So in other words, the default location to insert a new value is before the node I'm pointing at. Now, when I look at my little tooltip here, it's going to show me that my default parameters after equals false. So if I set false as my third parameter, and then I'll make a little comment here indicating what that's referring to, then that should put 150 before n2. So therefore I expect 100, 150, 200, 300. And sure enough, 150, 200, and 300, it worked just the way I expect. Okay, so let's do this again. Now we're going to say 250, and I'm going to say true. So this is going to insert it after n2, because after equals true. Therefore, I expect the values to be 100, 200, 250, perfect, and then 300. Okay, I have 2 remove methods, remove a single node or remove all nodes. I will start with my same 3-node linked list, and I'll say remove n2. So now I expect my linked list to go 100, 300. So 100, good, p next, 300. So n2 is removed. And now, of course, I can remove all nodes by saying clear. Now I expect everything from n1 on will be empty. And n1 is the empty node. We have exactly one status method, size, and size will have to iterate through the entire linked list to count the number of nodes. So we'll start with our same 3-node linked list, and we'll say auto s equals size n1. What's going to be the data type of s? Well, it's going to be a size t, which comes across as an unsigned integer. In this case, there are 3 nodes. To learn more about the implementation of the linked list, please see the definition section of the linked list chapter of the C++ Data Structures textbook.